Thank you very much for introducing me to the audience. I'm very happy to be here and thanks for inviting me here, Toyokawa-san. So before explaining my today's topic, I'd like to introduce myself to you. My research object is to understand what our society is and what it means to be human, especially from the viewpoint evolution. So my main methodology is mathematical biology, because my background is mathematical biology and evolutionary biology. And then also my methodology is evolution game theory and also agent-based simulation. But sometimes I go out into the field to observe reality and do some economic experiment with collaborators. So because the reality provides hint for studying a new research theme. So this is my current research theme. To understand how to sustain long-established mutual aid system, I focus on the ROSCA. Do you know ROSCA? Okay. ROSCA is a rotating savings and credit association, and this have existed all over the world. For example, in Japan, we call it Tanomoshiko or Mujin, and in Okinawa, it is called Moai. And Okinawa people do Moai a lot. And also some Tanomoshiko developed into bank. So some famous bank in Japan originated from this Tanomoshiko or ROSCAs. And also the concept of ROSCA has been applied to microcredit such as Grameen Bank. Maybe I think you know Grameen Bank because Dr. Yanasu won the Nobel Peace Prize. So maybe if you're interested in ROSCA, please search this word in the internet because I have less time to explaining. So then understand the long-established social system lead to a better understanding of what current social systems are. So that's the reason I'm focusing on this kind of topic. Also, recently I'm working for the division of labor and supply chain networks because human only divide their labor and also make a supply chain network. That's the reason I'm focused on these topics. And also recently, I joined a big project. Under this project, I'm working for the socio-ecological system. Then by using the coupling of social and ecological dynamics, I'm analyzing the socio-ecological system. So I sometimes visited the north part of Japan to observe the oyster farming and also the abandonment of the rice field in Japan to make a model. So, and also today's theme is about the rumor, gossip, and lies. I studied these topics from the end of the 1998 or something like that. So one paper was published in 2004 and the other was published in 2016. And also I'm working for this topic right now with my collaborators and my students. So today I'm talking about the previous studies published in 2016. Before that, I'd like to show you the three categories of rumor by the Kawakami and Matsuda. They are the Japanese psychologists. So one is the wild rumor, or maybe you know them because and wild rumor is rumors as social information. So this is a famous example story in Japan, the Toyokawa sinking bank run in 1973. Toyokawa is the same as Toyokawa-san, but there's no relationship between the Toyokawa sinking bank and, is that right? Correct? Okay, the high school girl chat about the Toyokawa sinking bank, and they said this is sinking bank would go bankrupt soon, but it is joking. However, the neighbor listened to that chat, and the neighbors believe it. and your neighbor transmit this information into their friend, and also the friend transmit this information. As a result, Toyota City people believe that, and then Toyota City people went to that bank to withdraw the money from the bank. So the bank had a hard time in that period. So this is a wild rumors, and also famous books entitled The Psychology of Rumor discuss about this kind of wild rumor. Maybe this is a psychology's book, so you know it. And also another category is urban legend. So this is a rumors for fun. So there's a very famous example existed. One famous example is a vanishing hitchhiker. It's a very famous American urban legend. Maybe you know it. Also, another famous one is famous urban legend was written in the books, The Rumeur du Oren. Sorry, I don't know how to pronounce it in France. But also these are very famous books, and this is very famous urban legend. So, and also in Japan, we have a very famous urban legend like Hanako of the toilet and the slit-mouthed woman. This is a very well-known urban legend. If you are interested in it, please see the movies like that. And also, third category is about the gossips about others. This is information shared by co-workers, colleagues, schoolmates, and local communities. So it is exchanged among somewhat close people. And these books say that the function of gossips are to transmit information, social sanction, or entertainment for talking about others. Then this gossip study has been studied from the viewpoint of evolutionary game theory and evolutionary theory. So Dan Berman, he is very famous evolutionary psychologist, discussed about the gossip in his papers. And for example, in Danvers 2004, thanks to the evolution of our language skill, we exchange gossip. As of that, we can get information and others, then we can trust each other. And also language has evolved to strengthen the social bond among people. Then the cognitive limit to the number of individuals to maintain a social relationship, or the famous Danvers number, is about 115 for people, thanks to the language, but about 18 individuals for primate. Also, recently, the evolution cooperation study deal with the gossips. So, in the Zakten famous book, the Zakten assumed that the player observed the reputation about the partner in the repeated prisoner dilemma game between two players. And also, Novak and Sigmund's famous study assumed that image score, and the image score is kind of a reputation of the past behavior which all players can observe. Then, this study said that the image score promotes the evolution of indirect reciprocity. And since that 20,000, the evolution of indirect reciprocity has been studied based on the framework of Zakten. I'd like to explain it later. Then I'd like to explain the evolution of cooperation a little bit here. So using the giving game as an example. So two players are chosen, and then one is assigned as a donor, and the other is assigned as a recipient. And the donor have two options. One is the giving a benefit, paying a cost minus C. So the recipient, in that case, recipient can get a benefit from donors, but donor have to pay a cost of cooperation. Another option is not giving a benefit without paying cost. So in this case, donor and recipient get any cost. The donor and recipient do not get any cost. Do not get any payoff, or do not need to pay any cost. So if the the donor chooses a cooperation. In this case, the recipient can get a benefit, but the operator have to pay a cost of cooperation. But if the partner also choose a cooperation in the next round, this previous donor can get a benefit from that cooperation. As a result, cooperator can compensate for the cost of cooperation. However, if this partner does not choose cooperation, it means this partner chooses a defection. In this case, this player cannot get any benefit. As a result, this previous donor could not compensate for the cost of cooperation. So this is the payoff matrix of this two players interaction. This is almost the same as the prisoner dilemma game. So if player 1 and player 2 choose cooperation, their payoff is B minus C. But if the player 1 chooses defection, but the player 2 chooses cooperation, player 1's payoff is B. But the player 2's payoff is minus C because player 2 choose cooperation. If the two players choose defection, their payoffs are 0. So this is just a prisoner dilemma game. Then, I think you already know, but the defection is a Nash equilibrium because if the player chooses defection rather than the cooperation, this player can get a more payoff than the player who chooses a cooperation. So, defection is a Nash equilibrium or the evolution stable strategies. But in our society, cooperation exists. So, researchers investigated what mechanisms promote the evolution of cooperation or mutual cooperation. So, there are many mechanisms investigated by the many researchers. And Martin Nowak reviewed this mechanism in 2006. This is a very famous paper, so that the reason I explain the mechanism using these papers. So Nowak, the 5 mechanisms is kin selection and direct reciprocity and indirect reciprocity and network reciprocity and group selection. So I only explained the direct reciprocity and indirect reciprocity here. So in the direct reciprocity, player interact repeatedly and play the prisoner dilemma game repeatedly. As a result, cooperation can evolve because the player can get cooperator get a more payoff than the defectors. And in the direct reciprocity, if this blue player cooperate with this player and this player observe this behavior or this player know the information about these players, this player may cooperate with this player because this player know that this player is a nice person. And then as a result, the cooperation can evolve. So according to the indirect reciprocity, Nowak and Sigmund did the epoch-making studies like this. So I like to explain this study here. So the group and the population size is 100, for example, in their studies. And then 2 players are randomly chosen from the population. Then one is assigned as a donor and the other assigned as a recipient. Then they play the giving game. Then this paper assumed the image score. Image score is a reputation or past history of the behaviors. So if the donor cooperates, the donor's image score increases by 1. But if the donor does not cooperate, the donor's image score decreases by 1. So it means that if the player A's image score is high, player A has a good reputation. But if image score is low, the player A has a bad reputation. Then in the giving game, the donor decides to cooperate if the recipient image score is equal to or higher than the donor's threshold K, or the K is also kind of a strategy. And also, donor decide not to cooperate if the recipient image score is lower than the donor's threshold or K. Then, in these papers, it is assumed that all players know the image score of all other players for simplicity. But this is a public information case. Then, after several repetitions, this process is repeated and repeated, and then the payoff of each player is accumulated per generation. Then, at the end of each generation, each player imitates the strategy or the K of players with a higher payoff stochastically. Then, after the end of the generation, new generation starts, and this is repeated and repeated until the, for example, the 1,000 generations or more. So this is just a dynamics of the image score using this example. And KA is a player A's threshold of decision making or strategy. And SA is player A's image score. So if KA is -1 and SA is 1, and B's image score is 1, in this case, the A's K, SB, the image score B is higher than the KA. So that this player, it means the player A decides to help or cooperate with player B. As a result, the image score of A increases by 1. So it means now the image score of A is 2. Then if C is a donor and A is a recipient in the gimmick game, in this case, C's K is 1 and C's image score is 1. In this case, so player A's image score is higher than the player C's K, so player C decides to cooperate with this player, cooperate with this player A. But if the player D meets with the player B, and player B's image score is 1, and the player D's threshold K is 3. In this case, SB is less than KD. So in this case, player D thinks that the B is a bad, so the player D does not help or cooperate with player B. As a result, the D's image score decreases by 1. So now the D's image score is 0. So if C meets with D, but this player's K or the threshold is 1, and D's image score is 0. So in this case, C never cooperates with player D. These things happens in the simulation. Then, after several simulations, the Nowak and Sigmund obtained this result. This is the beginning of the simulation. So, the simulation, and then vertical axis is the abandonment of the players, and the horizontal axis is the strategy. So, K is between -4 to 6, -5 to 6. Then initially, the frequency of strategies with particular K are the same. But after several simulations, and for example, after the 150 generations, the population is occupied by the player with the K equals 0. So it means the K equals 0 is an evolution. Evolution happened, and then population players in the population only have, almost all the players have the K equals 0. And then this paper says that fairness is evolved through these simulations. But there is some limitation of the image score. So according to the assumption of image score, if the cooperator player A did not help defector B, player A's image score decreases by 1 unit. Then observer, for example, player C, thinks that player A has a bad standing or bad reputation according to the assumption of image score. However, is a player who did not help a bad player really bad? So the researcher find out that the T1 strategy in the Zagden's paper, Zagden's book, overcome the limitation of the image score. So I like to explain the strategy of rule or strategy of T1. So if the good player, player A did not help the player B, who is a bad who has a bad reputation, but according to the T1 strategies, observer thinks that A is a good standing because player B player A did not help a defector B. So this is kind of a rule of the T1 strategies. But Zagden, the books only focus on one strategies. So many researchers working for these topics, and then some researchers find out that 8 types of strategy can be evolution stable strategy against defectors. This is a very famous paper written by the Otsuki-san and Iwasa sensei in 2004. So according to this rule, conditional cooperator can be evolution stable strategy against defectors. So the common feature of the leading, this 8 social norm is called the leading 8. Then I like to explain the common features of leading 8. Now, if the donor helps the recipient with a good standing, the donor's reputation is good. If the donor does not help a recipient with a good standing, the donor's reputation is bad. If a donor with a good standing does not help a recipient with a bad standing, the donor keeps a good standing. This is a common feature of these 8 types of social norm or 8 strategies. And then in their studies, simply assume that all players have the same reputations. However, different people have a different reputation toward a particular person. So recently, not only the public assessment model like the Otsuki and Iwasa's model, but also the private assessment model investigated. So, and Murase-san and Hirube's paper review the recent indirect reciprocity studies using these nice pictures. So if you are interested in it, please read Murase and Hirube's paper in PNAS. But this direct indirect reciprocity model assumes that the player's reputation strongly depend on the rule of leading 8. So, for example, if player A is a good person and player B is a bad person, and player A decide not to help this player B, in this case, observer thinks that the player A is still a good person according to the leading 8 or the social norm. However, when we consider the gossips spreading, this does not happen always. It means if A is a good person and B is a bad person, and A decides not to cooperate with player B, as a result, in that case, which gossip do you think player B spread, 1 or 2? And 1 is the player A did not help me, so player A is bad. And 2 is I am bad, so player A did not help me, so player A has a good standing or reputation. Which gossip do you think player B spread, 1 or 2? Okay. Many people, I think many people spread this gossips, but the current interdisciplinary study did not consider this situation. So we make a model to describe this kind of situation. So I did some research for these topics in 2004 and in 2016, and then I'll give you some brief explanation of our framework. So we consider the giving game phrase and the gossip exchange phrase. So in the giving game phrase, two players are chosen, and one is a donor and one is a recipient, and donor decides to give or not a benefit to the recipient. And also in the gossip exchange phase, two players are chosen, and one is a speaker and one is a listener, and the speaker spread the gossips about others to the listeners. And also, speaker have a chance to create and start a gossip with lies. Then, then the speaker spread the gossip to the listeners. But the listener can choose to accept or not the gossip. Then the gossip from others, using the gossip from others and also, his own or her own experience in the giving game phase, the player can judge who is good or who is bad. And then in the giving game phrase, using this information, player choose cooperation or not, or player choose spread the gossips about others. This is repeated and I get the result. So here I like to explain our previous studies result. So then I like to explain the model assumption of Seki and Nakamaru in 2016. So we defined the P-score. P-score is close to image score, but a bit different. So I like to explain the definition of P-score. P-score or SIJ is a player I's evaluation towards player J. Then in the beginning of each generation, SIJ is 0. Then SIJ is calculated as this formulation. So the first term is the difference between the number of games player I chose to cooperate with player J and the number of games player I chose to not to cooperate with player J in the giving game phase. And this second term is the difference between the number of sessions player I receives good gossips about player J and the number of sessions player I received bad gossips about player J in the gossip exchange phase. And also we multiplied rho Z by this difference. Then if rho Z is high, it means that the player weights gossip over the experience in the giving way. But if rho Z is 0, the player does not consider the effect of gossip. So rho Z is a weight of gossip over experience. Then, so if Sij is positive, the player I regards player J as good, and and the P-score is negative, player I regards player J as bad, generally. So now I like to explain the dynamics of our model. Basically, this is the same as this, but I like to explain it using our parameters. So in the giving game phase, two players are randomly chosen from the population. And then, for example, A is a donor and B is a recipient. Then if A's P's score toward B is higher than or equal to K. K is a important parameter or threshold. And the player A chooses cooperation. Otherwise, player chooses defection. Then after that, giving game repeated and repeated. In that case, we didn't consider the repeated game, but after this game, another new pair are chosen randomly from a population, and this process is repeated and repeated. And in the gossip exchange phase, for example, speaker and listener are chosen randomly from the population, and the speakers spread the gossip from face to face to the listeners. And also, if the speaker's P score toward the target is higher than QG, this speaker spread a good gossip about the target. But if the speaker's P score toward the target is less than the QB, the speaker spread the bad gossip about the target to the listeners. And P score is between QB and QG. The speaker does not spread any gossips about target. So QG and QB parameter is also important parameter for this model. Then also speaker start or create a gossip. So if parameter A is 1, a player can tell a lie and spread the false gossip about themselves. So in this model, the liar spread the gossip about self-promotional gossip, promotion. So it means that liars spread self-promotional gossips about themselves. Then speaker spread this kind of gossip. The listener decide to receive the gossip or not. So if the P score about the speaker is higher than QR, the listener accepted or received gossip. It means the listener believes this gossip. And then, based on the information from the gossips and the experience from the given game, the P score can be calculated, and then new P score can be used for spreading gossips or for the given game. This is repeated and repeated, then we can get a result by the agent-based simulation. So the K is a very important parameter. So if higher K means that this player is a defector, and player with a lower K means that this player is a cooperator. So please keep in mind this. So each generation have T unit of time, and one unit of time consists of giving game phase G times and gossip exchange phase R times. So that if G is higher than R, the speed of spreading gossip depends on G and R. So if G is higher than R, gossip spread slowly. But if R is higher than G, it means the player exchange gossip a lot. So in this case, the gossip spread fast. And so T and G determine the number of games. So if G times T is lower, this is kind of an indirect reciprocity situation. It means people do not interact each other in the giving game session, but people exchange, if people exchange rumor a lot, in that case, this is an indirect reciprocity situation. But if G times T is higher, people interact each other in the giving game session. It is kind of a direct reciprocity situation. So controlling the number of T and G and also R, we can unify the direct reciprocity and also indirect reciprocity in this model. And then at the end of each generation, we calculate the accumulated payoff of each player during the giving game phases. And then each player imitates the strategy set of players with higher accumulated payoff stochastically. And then a new generation starts, and then this process is repeated, and we can get a simulation result. And in this talk, in this research, I do not consider the social network structure. So we just assume that each player are chosen randomly and interact each other randomly. So objective of this study is, here is the objective of our study. We will investigate evolutionary condition that conditional cooperators can evolve when lies spread in the population. But so we have to define the lies in this model, because we can define the many kind of lies in our model. So before that, I'd like to explain one of the strategies, fair gossiper. Fair gossipers has a QG and QB are 0. So it means that this fair gossiper spread the fair gossip. And also, fair gossipers K, if the fair gossipers K, the threshold for cooperation is 0, we call this strategy Z-disk. So if K equal QG equal QB equal 0, it means the consistency between action and also the gossip. It means that Z-disk player cooperate with the player with a positive p-score and also spread the good gossips about the player with a positive p-score. But Z-disk does not cooperate with the player with a negative p-score and also spread the bad gossips about the player with a negative p-score. So we say that this player have a consistency between action and gossip. But we can consider that K is not equal to QG and not QB. In this case, there is an inconsistency between action and gossip. Even though this is not a lie, but inconsistent. For example, if QG is higher than K, in this case, if p-score is between QG and K, in this case, this player do not choose cooperation, but spread good gossip about this player. And if K is higher than QG, and also if the p-score is between K and QB, in this case, the player chooses cooperation and also spread a bad gossip about that player. So this is an inconsistency. Then we did the agent-based simulation in the population with various K, various fair gossipers with various K. Then this is the result, simulation outcome. The horizontal axis is the T, units of time per generation. So if T is higher, this is a direct reciprocity situation, and T is smaller, this is the indirect reciprocity situation. So vertical axis is the speed of spreading gossip, R over G. So if R over G is higher, gossip exchange a lot, and as a result, gossip spread first. So in this case, if R is 0, it means there is no gossip spreading in this case, and T is not so high, so as a result, defectors, in this case, defector means K is positive, then defectors evolves. However, if the R is higher than 0 and also T is higher and higher, cooperation evolves. So blue means that the cooperation evolves, and red means that defectors evolve. So if the R is higher, it means the accurate gossip spread faster and faster, then cooperation can evolve more in this case. So we introduced the self-gossiping ORD. This is a fair gossiper with telling a lie. So if strategies K is less than 5, player just fair gossipers. But if the K is higher than 5, in this case, fair gossiper telling a lie that I'm a good. So we call this strategy self-gossiping ORD. So it means this strategy spread the fair gossip about others, but this player just say, I'm good, even though this player is not good. So this is the agent-based simulations result. In this case, result is changed, especially since R is high. It means the gossip exchange first. In this case, the incorrect gossip or false gossip spread faster. As a result, cooperation cannot evolve anymore. In this case, this is a difference between difference. These are difference. So also we also consider the effect of biased gossiper. Biased gossiper's case, Kg is equal to Qb is equal to K. So this player have no inconsistency between action and gossip. It means they have a consistency between action and gossip. However, it's strange because if the K is positive, in this case, if player B is a biased gossiper with positive K, in this case, if the image score of B towards A is between 0 and QB, in this case, player B spread a rumor that A is bad, even though A's image score towards A is positive. So this is a biased gossiper. Also, if K is negative in this case, even though the player B's image score about player A is negative, but this image score is between QG and 0, in this case, player B spread rumors that A is good. So this is also biased gossiper. Then we only consider the various biased gossipers in the population. Then we can get the agent-based simulation result like that. In this case, even though the T is higher and also the speed of spreading gossip is higher, but defector evolves only in this case. So this is summary. This interim summary of a result. Without telling a lie, if there are no gossip spreading, R equals 0, or the speed of spreading gossip is lower, cooperation cannot evolve. However, if the speed of spreading gossip is higher, cooperator evolves more because a player can get accurate information about others. And also more experience in the giving game provides more reliable information about the player. Then a cooperation can evolve. But with telling a lie, if the speed of spreading gossip is very high, like R over G is more than 1, in this case, lie inhibits the evolution of cooperation. And also biased gossiper hinders evolution of cooperation even though T times G is higher. Now let's move on to these topics. we consider the three types of liar who are defectors. And here, all D means that the defectors with K is higher than 5. So this means that always choose defection in the given game. For reference, we consider two types of OLD who do not start right. One is non-gossiping OLD and other is fairly gossiping OLD. And then we consider three types of OLD starting right. One is self-advertising OLD and OLB OLG and OLG OLD. So I'd like to explain the non-gossiping OLD. This OLD never spread a gossip, so it's like always defectors. And fairly gossiping OLD always choose defection but spread fair gossip about others. Also, there is a three type lie. One is self-advertising OLD. This OLD only spread gossip that I'm good and choose defection always. This player never spread fair gossip about others. And OLB OLD always spread that everyone is bad. And also OLG OLD player spread the rumor that everyone is good and so I'm good. These are the lie. Then we consider the population which has one of all these and also Z-disks, and then did the agent-based simulation and get a result. Then we investigated what conditions promote the evolution of Z-disk or conditional cooperator when lies spread. So this is the result when T is 200. So it's kind of a more indirect reciprocal situations. The red means that the defector or the lying defector evolved, and blue means that Z-disk or conditional cooperator evolves. Then the horizontal axis is the rho Z. Rho Z is the weight of gossip over experience in P-score. So if rho Z is high, player weights gossip over experience. But if rho Z is smaller, player weights experience over gossip. So this and the vertical axis the R over G, so the speed of spreading gossip. So if this is a result when the population has the Z-disks and the non-gossiping OLD. In this case, if R is 0, there's no gossip. So in this case, the defector evolved. However, if R is higher than 0, in this case, Z-disk a bit evolved. Well, this is green, so a bit evolved. But this is the result when the population has fair gossiping OLD and also the Z-disks. In this case, result is close to the previous one. So if R is higher, the Z-disk evolves a little. Because this is green, not a blue. And if this is the result when the population has self-advertising defector and also Z-disks, in this case, it is hard to say that the cooperation evolves regardless of the rho Z. And also, if this is the result when the population have all B, all D, and Z-disks, in this case, all B, all D always evolves regardless of the parameter rho Z. And also this is the result when the population has all G, all D, and Z-disk. In this case, all G, all B evolve regardless of the parameters. However, if T is higher, it means T is, T is 100. In this case, this is more direct reciprocal situation. In this case, result is changed. In this case, T is higher, so the a player play the giving away a lot, so they can get the accurate information from the game. As a result, if R is higher, this can evolve. If the difficulty is non-gossipers or the fair gossipers or self-advertising. But if the defector are all B, all D, or all G and all D, in that case, all D evolves if the row Z is higher. So now I'd like to introduce the QR. So before this slide, we consider the situation where that all players received all gossips, but player can choose the gossip. So QR is the threshold of the listener's criterion for receiving the speaker's gossips. So if QR is high, it means player A choose the gossips. It means player only listen to the good gossip from the reliable players. Then in this case, the result is changed. So if T is smaller, in this case, especially if the when the population has the fair gossiping all D and Z disk, in this case, Z disk can evolve. However, other case, all D evolve. Then this result when the T is higher. In this case, Z disk evolves more under the same situation. So this is summary of our result of our research. Without telling a lie, Z disk evolves more as accurate gossip spread faster. So with telling a lie, such as self-promotional gossip or ungrounded gossip, Z disk or conditional cooperator can evolve when the players weight experience over gossip in higher T. And thus when the players only receive gossip from more reliable speakers. So this is the end of our talk. And I'd like to show you our future directions. In that study, we didn't consider the effect of social network. So I and my student are working for the network topic. It means we introduced the lattice model in this model, and we are analyzing the result. Also, Bai and my student making a more general model for this topic. And also we like to consider other types of lies in the near future. So thank you very much for listening to my talk.